we're asked to draw the graph, and it's just a sketch of y equals 2 sine pi t plus 1. Our general form that we came about in the previous talk was y equals a sine b outside of x plus c plus d. So that's the general form. So we need to knock this into shape. Now, we've got to get the variable now. In this case, instead of being x, we've got it in terms of t. So on the normal x-axis, we will have t. But we must just isolate it by itself. We've got pi t at the moment, so there's not much we really have to do here. So we can write y equals 2 sine, and we put the pi is just a number outside of t plus 1. So we've got it pretty well now in this form here. We could have put t plus 0 to indicate that our c value would be equal to 0. If you want to do that, that's fine. So we've got, let's now go through and identify, using this and knowing what A, B, C and D are, we can actually write down using our example here. So we've got A, which is equal to the amplitude, and that lines up with the number 2. Now it's positive 2, so we've got no reflection or anything going on. So instead of our sine graph oscillating between plus 1 and minus 1, it's going to go between plus 2 and minus 2 if it was just 2 sine. But we've got something else going on, which I'll talk about in a minute. All right, so its amplitude is 2. The period, 2 pi on b equals, now my b is what's outside the bracket. Now what's outside the bracket here is pi, so it'll be 2 pi over pi. The pi's will cancel, equals 2, and that is the period. My c value is equal to 0, so therefore no horizontal shift. And d plus 1 equals 1, so a vertical shift. All right, so let's build it all now and put it all together. We'll get some axes now. As I said, it's y as a function of t. So if we just draw, so here's my t, and here is my y. Normally, the sine graph, and let's just do it in steps. So I'll start with yellow. We've got 2 pi. So well, why don't we just spread this out a little bit? So we've got 1, 2, 3, 4. So 2 pi out there. And if it was just y equals 2 sine of t, it would go between plus 2, so if that's 1 and that's 2, it would go between plus 2 and minus 2, and it would go like so that is the graph of y equals 2 sine of t. Okay, 2 sine of t. The effect of the 2 is, instead of going between plus 1 and minus 1, is to go there. Now, we have got a period of 2. So 2 is, so that's around about 6. So 2 is going to be down here somewhere. So let's change down. So that's pi. If that's 2 pi, that'll be pi, which is 3 point something. So it'll be 2. So let's just make that 2. And then we've got halfway from there to there will be equal to 1, halfway and halfway. And so what is this graph going to look like? It will go so the blue graph is y equals 2 sine of pi t. So period is equal to 2. So I've taken the effect of the A and the B now, and we get that graph. So that's what's happened there. Finally, we've got to take into account that we've got a 1 vertical shift. So instead of my equilibrium line being there, my equilibrium line will now be, let's go for purple, eh? So here is my equilibrium line. So my graph is going to oscillate around that, and it's going to go 2 units high. So it's going to go up to there, and it's going to go 2 units below that. So what I've got to do is to move this graph up. So it starts, instead of starting down there, it's now going to start up there. This point will go up to there. This point will go up to there. This point will go up to there and back. And it'll go through 2. So we've got a graph that looks like and that one goes up to there. Okay, and it continues on. And it continues this way as well. So this is my graph of y equals 2 sine pi t plus 1. So I've taken into account the fact that we've got an amplitude of 2. So the distance from the peak to the trough, or the maximum to the minimum, is 4 units. So it goes from -1 to +3. So that's a total of 4 units. Half of that is the period. Is the amplitude. Half of 4 is 2. So that's correct. That's my amplitude. The pi comes out, 2 pi on pi is the period, 2 pi on pi is 2, so 1 complete cycle. So there is 1 period between 0 and 2. And then the +1 moves my equilibrium line up 1 unit. So the middle of the graph, if you like, or the line about which it oscillates, has been moved up 1, which means that my maximum from before has got to go up there, and this has got to go up there. All right, we'll do some more examples because there's a lot of work involved in that, and after we've done a couple more, you might get the idea of how it all works.